Okay, question 2b from the exercise 4e, find the inverse Laplace of 3s plus 5 over s squared plus 6s plus 1. Okay, first of all, is it possible for you to factor s squared plus 6s plus 1? If yes, then you can solve it using partial fraction. Is it possible? S squared plus 6s plus 1. If yes, you can solve it using partial fraction. If not, you have to do completing the square. Okay, so this one, we'll do the s squared plus 6s plus 1. We're completing the square. Okay, then we're going to do 3s plus 5. So to do the completing the square, if the coefficient of s squared is not 1, so you have to factor out. So this case is 1s squared, then you can open your bracket. So s, and then the linear term, you got plus 6s. So the linear term you divide by 2. So plus 6 divided by 2, you got plus 3. Okay, close the bracket and you square it. Okay, when you expand back, you get is actually s squared plus 6s plus 9. Okay, so we get this term s squared plus 6s, but we extra plus 9. So we need to minus 9. Because s plus 3 squared, you have extra extra 9. So you need to minus 9 so that it balance back. Then we already have plus 1. Okay. So you got, and then you notice you have here, this is s plus 3. To make it as a function of s plus 3, s here, you need to plus 3. So 3 times, so if you plus 3, so total you got extra term, which is plus 9. Yeah. This one extra plus 9, that's why you need to minus 9. Minus 9, and then you plus 5. So when you expand back, you get back. Okay, it's actually 3s plus 9 minus 9. So plus 5, get back this one. So this is a s plus 3 squared. So minus 9 plus 1. So minus 8. Okay, simplify it. So you got 3 times. So s plus 3 minus 9 plus 5, you got minus 4. So divided by s plus 3 squared minus 8. Okay, and then we can break the numerator, become, break the numerator, then we got 2 term. 3 times s plus 3 divided by s plus 3 squared minus 8. So minus with the inverse Laplace of 4 times s plus 3 squared minus 8. So both term are actually a function of fs minus 4. Mean both term you have the actually the inverse Laplace of f s actually minus negative 3. So both term is actually function of fs minus negative 3, where the answer you should have exponent a at ft, where in this case the a is actually negative 3. Mean fs minus a. So the a, you compare, is a is actually negative 3. Hence mean the answer you should have the term exponent negative 3t. Exponent negative 3t. ft is actually inverse Laplace of your fs. So mean these two term you should have exponent negative 3t, negative 3t, and you the bracket. The ft is actually inverse Laplace of fs. Fs means s plus 3 replaced by s. So 3s. So this is s squared minus 8 minus, okay, the inverse Laplace of 4 times. So, okay, s plus 3 become s plus 3 squared become s squared minus 8. Okay. And then, okay, now you can do the inverse Laplace for 3 times s over s squared minus 8. You should have, okay, factor out 3. Then the inverse Laplace of s over s squared minus 8 will be, this will be cos sub 8t. No, I got one. Because this one I factor outside already. So exponent negative 3t. Okay, this one you get 3 times hyperbolic cos, okay, sub 8t. Cos 3 you can, okay, factor outside. 8, okay, is actually sub 8 squared. So 3 cos, okay, sub 8t. And then the second term, okay, if you multiply sub 8, then you need to divide by sub 8. So that's why you have 4 over sub 8. And this term you will get sin sub 8t. Okay, so you may simplify or you may leave it this form. Exponent negative 3t. This is 3. This is cos, okay, sub 8 is 2 sub 2t. So 4 sub 8 is 2 sub 2. So to eliminate the sub 2 at the denominator, I multiply sub 2, I divide by sub 2. And then sub 8 is actually 2 sub 2t. So I got 3 cos 2 sub 2t. Okay, 2 times sub 2 is actually 2. Sub 2 times sub 2 is 2. So cancel with this 2. So we left minus sub 2 sin 2 sub 2t. Okay, this is using completing the square. Because, okay, we cannot factor out sin squared plus 6s plus 1 become 2 linear factor. We cannot factor out. If we can factor, then we use the partial fractions. Okay, let's check the answer for E. Question 2b. Yeah, correct. So, okay. So this one is using completing the square. So any questions here?